Gabe is our one of our tutors. I think give me just a, okay. I need to invite. I need to send him the link. Just a sec. Okay, so a 1D graph is a line. Okay, so what is a 0D graph in a sense?
It's nothing.
It's nothing. I mean, it's actually a point. It's something.
Oh yeah, like a dotted point, like 5, 7 or something, but like not anything else.
Well, so yeah, I mean, it doesn't even have a coordinate, right? 5 7s in 2D, what you just said. But so yeah, so just thinking about dimensionality, which is a great exercise. Sorry, I'm emailing this. This is very bad. Okay, there we go. Yeah, okay, I just sent it to you. Sorry. Okay, so yeah, so zero. So this is actually kind of a cool aside. And today's lecture, you know, it's sort of about one big topic, and there is no quiz today. Just a disclaimer, because you know I want to give you some time. So there will be like a bigger quiz tomorrow. Okay, but that doesn't mean you should just leave the lecture. Please don't leave.
So there's going to be no attendance?
Oh, I shouldn't have said that. Please don't leave. Please be a good student. Please stay. Okay? Because if you miss today, you're kind of long. Don't leave. Okay, thanks. If you miss today, you're gonna regret it. Okay? Okay. Sorry, let's get started. Okay, so so dimensionality. Okay, well, this notion of dimensions. This is actually very nice, and this is not something that you're about to get some nice like kind of philosophical stuff. So how many dimensions do we live in?
4D?
3 or 4.
So someone said 4. So who said 4?
Julia.
Okay, Julia. Why 4?
Because 4D is like, it's like in those special Lego movie theaters where like a dragon sneezes, you feel the snot on your face.
Oh, I see. Okay, so you're talking about like in theaters, you know, and sometimes in theaters, like you have the seat and then they make it interactive, so they make it physically.
Yeah.
Okay, so is that truly 4D?
No, it's like an envision of 4D. It's not actual 4D.
Right. So
if it was actual 4D, like it would actually be happening. Like a dragon would be real.
Yeah.
Okay, so strange things happen. So let's build our way up. So apparently very strange things are happening here. Like you would have real dragons and things would be chaotic. Okay, but let's see. In 1D, first of all, 0D is a point. Okay. So it's impossible to depict 0D. It's in fact sort of wrong to depict any notion of dimensions because we live in 3 dimensions. And actually you're looking at a 2-dimensional screen. So when I just put a point here, you know, I can zoom in on this point and it has some width, you know, and it actually has some, you know, there are some dimensions to it, right? So a point is, you know, it doesn't have any area, right? By definition, it doesn't even have a length, right? It's just a point. So it's very hard to sort of grasp this notion of point. And yet points make out everything, right? You know, you can decompose anything into a set of points. And this is called a locus, right? And it's a big thing in geometry. How about 1D? This is what?
A line.
A line. And let's see. So this is 1D, right? You all agree?
Yes.
Is this 1D? Call this line L and call this line M. Is this 1D? Yes, no, maybe.
Maybe.
Maybe. Okay. So Selena said no. So who? Okay. So some people think that to this day that the Earth is flat. Okay. You've heard of this flat Earth movement?
But why?
Okay. So in a sense, when you look at the horizon, right? It looks like line L, right? And if you just
it is one-dimensional, I think.
Sorry.
I think it is.
You think that this is 1D?
Yeah.
Okay, so we're gonna sort of. There are 2 explanations. Okay, so you can think of the Earth as flat. Okay, and that when you zoom out of the Earth, if you like the people who went up to the SpaceX, who took the SpaceX rocket to the ISS recently, I don't know if you all followed that, but when you leave the Earth, you can actually make out its curvature. But we're not, as on planet Earth, we are not confined. So we are confined to the surface. We can't go inside. We can't move in this. That would be like, to some extent we can, but we can't like go into the mantle of the Earth. We can't go into the, you learn this in like elementary school, how there's a core, two different cores, and the mantle and the crust. We can't do that as such. So in a sense, we're confined to the plane, right? So like planet Earth, the flat earthers say that this is 2D. Well, the people who have it right, the scientists, and most people today would also say that this is a 2D plane, even though it's a three-dimensional object. It's 2D because you're confined to the surface. But what's different about this? What makes it different from the plane here?
It's like it actually, like, it's spherical, so like it can have more, like, well, I forgot what the word, like, so like its diameter, so maybe like its diameter would be, or its radius would be one-dimensional, but since it's like a circle, inside the circle, like, you'll see points, which that would make it two-dimensional.
Okay, so you sort of said a lot. Someone else was going to say something?
Circumference.
Circumference. Okay, so I don't know how that's really related, but basically it's, I think, what was it, Adi? I think at the beginning of what you said, I think you kind of hit on it, that this is curved space. This is just a curved plane. And this is, flat space. Okay, so you can actually describe, so similarly, this is in 2D, but for a line, you can have a straight line, you can have a curved line. There's nothing, you can define a circle in terms of 2D, but you can also define it in terms of 1D. Okay, so this is sort of, okay, for the 11th and 12th graders, okay, 9th and 10th graders will never have seen this. But how would you do this? How would you define? So you've all seen, I'm sure many of you have seen, that the equation of a circle is something like this for a unit circle, right? Equation of a circle. You need two parameters here. You need x and y. This is 2D space, right? You have two dimensions, x and y, right? X, y. But the way you would express a circle as a line, as a curved line, is using a different coordinate system. So here, you have Cartesian coordinates, or x and y. Here you would use a totally different coordinate system called polar coordinates, which is a circular coordinate system, okay? So you have, instead of x and y, you have r and theta. And so you could describe this circle, for example, of radius 1 as r equals 1. And so this is the equation for the circle. And you can see that there's one dimension here. Here you had two dimensions. Here you have one. Okay, so this is a long aside about dimensionality in answering someone's question about what a 1D line is. But basically so you can have curved lines, and you can express those curved lines in either 1D or 2D, was sort of my point. And we live in 3D, so then, we talked about 2D, and that's the plane. And then 3D is space, as we know it, okay? So a 1D line, what we're gonna be graphing today, it's just a set of points confined to this line. So we usually refer to this dimension as the x sort of dimension, or x-axis. And we'll make many graphs today where we're drawing, okay, on this line. What is, by the way, before we leave this aside, what is the fourth dimension? Is it just like sitting in the, you have the movie, like the seat, and then they like have like little things in the back of the seat? Is it just like sensation? So someone said that the fourth dimension is like sensation, but sensation happen if you think of like, just if you're sitting at a table, just touch the table. The feeling of touching the table happens in 3D. You're moving in the XYZ direction, right? That's a three-dimensional phenomenon. So it's not really sensation, but what is the fourth dimension?
Fourth dimension is something that's like exterior to like the third, like, so the third dimension is like the highest, like we've known for a while, but the fourth dimension, like it can add different, like maybe, so like a projection that goes outside of three-dimensional space.
Sure. So it's more than, yeah. So we can project the fourth dimension in 3D, and in fact, that's exactly what we do as we sit here and talk. what is that projection? It's the sort of idea of time, right? So time is the thing so we can travel in 3D. You know, you can jump up and down, you can run around. That's moving in 3 dimensions, but you can't travel in time, and yet we feel it passing us. So time is like projected onto 3D. So time is the 4th dimension, right. And so we can't interact with it in the sense that we can't travel in time. But this is sort of, it is very cool. So you'll hear, like, when talking about 4th D or in fact ND, this goes on and on, that instead of using point lines, but you'll see this sort of preface, hyperspace. So if you have a 4th dimensional cube, it'll be called a hypercube, or 4th dimensional sphere will be called a hypersphere, so on. So alongside, we're talking about time travel now. That's amazing. Yeah, so it is amazing. And I hope that this course provides the background that you'll need to take to study some of these things later in life. Even just like in a few years, okay? Like maybe you'll get to the point where you get to study this thing called relativity, which relies on the notion of 4D. And it's really, okay, so this is a long aside, but I'm sort of taking time to inspire and give some context, okay? But yeah, relativity necessitates that you consider time as a dimension, and very strange things happen when, say, you travel near the speed of light and return to Earth. If you have a twin, and you, or someone your age, and you go fast, to near the speed of light, and then you return, it turns out that when you come back, your twin might be long gone, and you'll be almost the same age. Very interesting. Length is no longer well defined. It's amazing. So the entire idea of simultaneity is no longer valid. So anyway, so long aside, that's sort of what a line is, okay? Sort of the context of 1D in terms of the other dimensions. Okay, so I'm not going to do this often, like these long rambling asides, but I thought because we have a little bit less today, and because you all have made the effort to be here. Okay, I don't know what the flash paradox, but let's continue this discussion maybe afterward, okay? Okay, so Gabe has offered walk-in hours, so to speak. So we have office hours, which can be found on the course website. You all have been aware of this now for almost 2 weeks. Gabe, who is our wonderful, he's a PhD, worked at TI for many years, very accomplished guy. He's offered that if you ever need help, like instantaneously, say we don't offer office hours at some odd time of the day, even though we do have office hours every day of the week. If there is a time that we don't have office hours and you need help like urgently, just email Gabe, and his email is on the website, okay? And he'll set up like a one-on-one thing for you. But don't rely on it. We don't want to bombard Gabe with requests to do personal.
Oh, hey, I'm online here, so let me just refine that.
Go ahead.
I'm willing to do this, yes, once in a while, but please don't make it, I need help in the next 5 minutes. I may not be on my computer to see that message. So to some extent, say something, send me email, which you all have my email. Send me email that, hey, this afternoon at 3:30, could we please get online? And I'm usually on mail multiple times a day, but not all the time. So do it so that I can see your message, and then we'll arrange for the meeting, okay?
Great. Yeah, thanks, Gabe. Yeah, so so give him some time, and he's there to help. Please do attend the other office hours. Today at 1, I think Patricia has her office hours. And I've heard really good things from Patricia about you all, and supposedly people are getting a lot out of this. So yeah, please make use of all of these resources, okay? Here's some requests from Anya, one of our tutors. So some of you have her as your personal tutor, but I think this should apply to everyone. So when you're submitting your homework, use some relevant subject, okay? Like subject line, okay? So this week, maybe like math homework 2 or something, right? Just address things so we know kind of, the tutors are getting a lot of emails, so this will help them. Please read all the questions all the way, okay? Many people are getting like things wrong for silly reasons because they're just not reading the entire question. Okay, circle your final answer if possible, or just make it very clear to the tutors what your final answer is. You know, space out your homework. Like, take a lot of paper. The more paper you use, almost like the better. It's bad for the earth, but it makes it clear. Okay, so your brain needs space, and so do we. For the distributive property questions, if you're doing corrections, which I think most of you are, simplify all the way. Okay, so you know, just write things in simplest form. I don't think I need to explain. And many people are forgetting like the definition of the square, which you all should be past this. Okay. Okay, and also please don't send your math homework to your reading tutor. We're running these courses differently, and a lot of the English tutors got math homework from people. Okay, so just be aware of these things. Okay.
Do you like how do you differentiate the two?
So the math tutors are listed on the math website, which you all should have. And if you want, can someone just find it and
That website, does that say the CAG website?
Yeah, it's actually my initials. I wish I didn't. Yeah, yeah, the one with all the numbers. In fact, here, I'll just do it one more time. I think I've posted this like there we go. Okay, thanks, Adi. You beat me to it. Yeah, so it's on the contacts page. So those are the math tutors. They're assigned by first name. So my first name starts with CH. So if I were a student, I would go down and look, and it says tutors for first names. You know, Aaron through Brittany. So my tutor would be Christian because my first name is starting with CH, and that's between Caleb and Jessica alphabetically.
And then how would you know for reading who your tutor would be?
Email Pratik. I have no idea, honestly.
Okay.
How they're reading. Yeah, I have no idea. These courses are being run separately. Okay, so yeah, so email him. Okay, so just a quick review from yesterday. So sorry for this long introduction. This will not be every day. You know, most days we'll get, like in the past, we'll just get straight to it. But I just wanted to kind of give some context, give some breathing room, and then clarify some things. Okay, so how would we do this problem? We talked about inequalities, right? And so this is
3 to both sides.
Say that again.
Add 3 to both sides.
So first of all, what are we trying to do here? So who said that? Thanks for asking. Thanks for participating.
I am Rosie.
Okay, so Rosie, thanks. So how many dimensions are there in this problem?
2.
2.
2.
And what are you trying to solve for something? Are you trying to solve for X? Okay, so X might be worth looking for, but I mean, does it make, if you have 2 dimensions, this is not, you know, this inequality does not have like a solution, right? Just as generally y is mx plus b, this thing doesn't have, you know, you can find some important points. For example, the X-Intercept. What is going on? My screen just flickered. The X-Intercept minus b over m, or the Y-Intercept b. Like, there's some important values on this graph, but you know, this thing by itself doesn't have like an answer to it. It's a whole set of numbers. It describes a whole set of numbers. So this is already in this form, roughly, right? You have y, y, m, m, x, x, b, b, right? And we said yesterday that there's a lot of equivalence between, no pun intended, between equalities and inequalities. So what if I write this like this? Can't I graph this? We spent the entire first week graphing these kinds of things. Right, Rosie?
Yes.
Okay, so I'm just going to graph it. I assume everyone can do this by now. It looks like this, right? Where this is -3, and the slope is 10. And if I wanted this point, it would be minus b over m, and minus 3 is 3, m is 10, so this is the point 3/10, 0, right?
Yes.
Okay, and so now how do we convert from the equality to the inequality? What is this?
The shaded region.
Right. So I think Adi really understands what's going on here, but I have a feeling not everyone does. So how do we go from here to here? Adi, can you elaborate?
So the inequality. So like it's determining. Instead of the equal sign, it'll say like, so say the equality was less than, then the line would be dotted or the shaded region. So since y is less than, the shaded region would be underneath the line.
Underneath.
But if and if
so
it was
here's
greater,
a solid line because we have the equals to part in the inequality, and
so it's included.
Right, and it's less than. So the y value. If you're confused about whether to shade on this side or this side, I would just take a point that is on this side, or maybe a point. So let's take a point like 0, 0, which is on this side. So 0, 0. If I put in 0, is 0 less than or equal to 10 times 0 minus 3? Is 0 less than -3? No. It can't be this side. So all the points on this side satisfy the inequality.
Yeah.
So this is what we talked about yesterday. Okay. Just to review. And I'm going to skip this example. This is the same kind of thing. In fact, okay, I'll do it really fast. Okay, my speed. So this is point slope form. So we know that a point on this line is 1, 1, right? Using your point slope form. So here's a point, and I know that the slope is -4. So the line looks something, I missed the point. Anyway, say that that's the point, 1, 1. So I know the line looks something like this. And if I wanted, I could find this. But anyway, I already have 1 point on the line, and I don't need anything else. And because it's greater than or equal to, I'm going to shade on top. Make sense? If you wanted to find this point and this point, you would convert this to slope-intercept form. And the way you do that, I'll do it right now. This is a 4. Sorry, my y's are looking like 4s. Minus 4x is greater than plus 5. And so this is b. So this is 5, 0, 5. And your x-intercept is minus b over m, which is 5/4. Okay, so that was sort of done at my speed. That's how I would do it. So if it doesn't make sense to you at that speed, just take your time with this after the class, okay, and review, and then the homework will help, okay? So today's topic is absolute value. So what is absolute value?
Getting positive numbers through a sign.
Getting positive numbers.
Like through signs only, like, because sometimes you might not be able to get one.
Right.
Le digo gracias ahorita.
Okay, so Solina has said distance of a number from 0. So that's actually one of the formal definitions, and that's, Adi, that's sort of the formal definition of what you said. So distance from 0. So say I have our 1D line, which we talked about extensively in the beginning, okay? And say say this is 0. Say that this is 5. Say that this is -pi. What is the distance from 5 to 0?
5 units.
5, exactly. What is the distance from -pi to 0?
5 units.
Is it pi or -pi?
Pi.
It's just pi.
It's pi because we're talking about a distance. You know, a distance, just think of space itself. So the distance from, home to school. Can it ever be a negative number?
No.
No,
No.
Distance in itself is just, it's defined. Negative distance, think of, how if you think of distance as the number of steps you would take, that's how ancient people defined distance, right? Like the stride. They would say, okay, 3 strides from here to my desk, 100 strides from here to my friend's house, that kind of thing. Doesn't even make sense to have negative strides. I mean, you could maybe like walk in the opposite direction, but that's also
that's still going in a direction.
Right. Yeah, that still counts as a stride, as a positive stride, right? So this is sort of why absolute value is meaningful to us, because distance, from what we understand, is a positive quantity. So this is one of the definitions. Okay. It turns out there are 3 definitions. So we said 1, distance from 0. The second definition is maybe less intuitive, okay? But say you have the number a. So first of all, with point 1, if you take the absolute value of a, that basically means that according to this definition, that you just keep the positive. Okay, so if it's a negative number, it becomes a positive number. So we'll get to that. We'll sort of formalize this. But basically, the absolute value is greater than 0 is what this statement is saying. The absolute value or equal to. The absolute value is always greater than or equal to 0. Okay, you can't have the absolute value of something give you net. So for example, you can't have This is an impossible statement, right? This right-hand side always has to be positive, or 0. Okay. The second definition is maybe less useful. Okay, so whoever's talking in the background, just mute your microphone. Okay, thanks. Okay, this is a less useful definition, and because it's a definition, we write 3 bars, sort of. This is something you'll get used to in college, people writing 3 bars for definitions. So this is sort of less useful, but let's just go with it for now. So the square root of the square of something is the absolute value of something. Okay, the third definition is supremely important, and it's going to be the hardest conceptual part of today. And it is the truly like the nicest, most formal, most general definition of absolute value. And it says that, and this is written on your homework if you forget, okay, I've defined it on the homework. It says that the absolute value of A is one of 2 cases. It's either A, if A is positive, and it's negative A if A is negative. And I'll include the equal to, you can include the equal to part in the case that A is 0, as long as you include it on 1, okay? So don't worry, don't get hung up on this equal to sign. It's just a technicality kind of. But we have to include the case that A is 0 in one of these cases. Okay, so this is a formal definition, and it looks horrendous. It looks very mathematical and very sort of hard to get your mind around. But this is the way. If you follow this definition, if you memorize this, if you write it enough times, you'll sort of get past the roadblock of absolute value, the mental roadblock, and life will become a lot easier. And so we're going to use this quite a bit in our examples today. And just to get some intuition, let's apply these 3 definitions of absolute value to some numbers like negative 10. Okay, so according to definition 1, what is the absolute value of negative 10? 10, because definition 1 says you just take the negative number, put absolute value bars on it, and it becomes positive. That's right, whoever mentioned in the chat. According to definition 2, which is this one, that the square root of square of A is the absolute value of A. Here, according to that definition, this thing equals what? The square root of negative 10 squared. Well, what is negative 10 squared?
That's just 10.
Yeah.
Or, well, the square roots will cancel out anyway.
Okay,
so
you're right about the final answer, but let's do it step by step. That's the point.
100.
Yeah, so negative 10 squared is negative 10 times negative 10. That's the definition of the square. And negative 10 times negative 10 is positive 100, note. And what's the square root of 100?
10.
10. Yeah, so look, we got the same answer twice. Make sense? So it works with definition 2. Now what about definition 3? And I'll rewrite it. That the absolute value of negative 10 is either negative 10 if negative 10 is greater than 0. Note that this is not true. Or negative of negative 10 if negative 10 is less than 0. And so let's look up at the statement and see if this matches. Does what I wrote match the formal definition? Look. Absolute value of A. Yeah, so so A here is 10, right? Sorry, negative 10. So I just replaced everything in its definition with negative 10. So negative 10, which is A, if A is greater than, I forgot my equal to sign, right? So the first statement is good. Second statement, you take the negative of A, which is negative, and A is negative 10. So do you see how I followed the definition perfectly? Yeah?
Yeah.
Okay.
Yeah.
I hope this makes sense. Now, what is with this first statement? That the absolute value of negative 10 is negative 10 if negative 10 is greater than 0. Is negative 10 greater than 0 or equal to 0? Is this statement true?
No.
No, even a kindergartner knows. Well, I guess, I don't know. Kindergartners don't know negative numbers, but I don't know, 5th grader. This is not true. So this statement is not true. But is negative 10, see, if negative 10 is less than 0, is this true?
Yes.
Yes, and so that is the case that is actually mathematically valid. And what is negative 10?
Positive 10.
Positive 10. And so again, we got the same answer. So I've sort of given you by example the validity of these 3 statements. And you could do the same thing for like another number, negative 2 pi. Of course, you'll get negative 2, you'll get absolute value of negative 2 pi to be 2 pi, just as you got 10 in this case. You can verify for yourself. Okay? Using the 3 definitions. Now let's apply to some more general, so these were numbers. Now let's apply, let's apply the 3rd definition. Well, let's apply all 3 definitions to some variable x. Okay, so that's not a number. This can be anything. This can be negative 1, I don't know, 1 pi, e, whatever, negative e, right? It can be anything. So let's see if it works. Yeah? So according to definition 1, what is x? What is absolute value of x?
X. Positive X.
Well, see, I just said x can be negative. So definition 1 is not a good way to talk about algebra. It's a nice way for 6th graders to think about what is the absolute value of negative 10. Oh, you just take away the negative sign. But see, x can be negative or positive. So you need to actually use the 3rd definition. The 2nd definition, if you try to use, so this, I basically said the 1st definition is pretty, it misses the mark. Okay, it's too trivial. Like you're basically asking what is, so this is the x-axis, and you're saying what is the distance of x from 0? Well, is it just x? Well, x can be negative. So say x is negative 5. Is the absolute value of x then negative 5, as you just suggested? You just said that the absolute value of x is x.
No.
No, the absolute value can't be negative. So you see where this definition breaks down? Definition 1 is actually too rudimentary. That's too middle school for us. Okay, so definition 2 says that the absolute value of x is square root of x squared. This is a better definition. Okay, because you can put in numbers and you can see that this actually gives you all positive numbers, first of all. And this definition matches the more formal definition, which actually gives you a satisfying answer. So if you were to, so you can see that the only solution to this equation, you can square both sides, right? And 0 squared is 0, and you're left with x squared is 0. And the solution to this equation is x is 0. Technically twice. We'll get into the, okay. But the solution is x is 0 by definition 2 to this equation. Now by definition 3, let's do it formally. Okay. I want someone to tell me definition 3. Now maybe looking at your notes. What is absolute value of x according to definition 3? It's either, you have 2 cases.
It'll be either be x is
X is greater than 0.
if it's greater than 0.
If x is greater than 0.
And less negative x if it's less than 0.
Yes. Yes, so this is applying the definition. Now look, this took me like a long time to get my mind around. So it's okay if you will have to play with this and do the homework and really make sense of it, okay? For it to really click. But this is exactly right. And now we can set each of these equal to 0. So look, this is why this equal sign is important, because I captured the case where x equals 0, right? So absolute value of x is x if x is equal to 0. And therefore x is equal to 0. So this gives you the solution. This case is not relevant because the equals to sign is not included here. Does that make sense? This is kind of abstract. So write this down, think about it. Okay, so there's only one solution to this equation, and it is that x is 0. And we got the same solution from both methods. Okay, so we're gonna get a lot more practice with this in just a sec, okay? Let's apply the 2nd definition to this, okay? So we have 2 cases. X plus 1 if, what is the condition?
X plus 1 is greater than or equal to 0.
Very good, very good. And what's the other condition?
X plus 1 if x is less than 0.
Right, well, you have to have a minus sign out here, right? Just look at your definition. I know I'm just kind of asking you to regurgitate definition, but yeah, you got the condition right. Okay?
I have a question.
Go ahead.
Can you just distribute the negative x? Like it would be negative x minus 1?
Yes,
Yeah, that was exactly
the next step. And so now we have these two cases, and according to this equality, both of these cases are 0. Right? So ignore, so I'll rewrite it so it's less confusing with these conditions written here. So basically we have two cases. X plus 1 is 0, and negative x minus 1 is 0. And I did exactly what you suggested. I distributed this negative. That's a very good point. That's exactly how you'd proceed, right? So what's the solution to this equation? Come on.
-1. Oh, sorry.
Yeah.
I was
And
slow.
what's the solution to this equation?
-1. X.
Yeah. So you got the same solution twice, right? And kind of fittingly, we got, from this, we had, remember when I said it was 0 twice? So the meaning of twice is actually very important here, but we'll get to it later. But basically the solution, what they're gonna ask you on the SAT is, what is the solution? The solution would be -1. And if you look at this thing, you can think of any number you want to satisfy this absolute value. But it turns out that -1 is the only thing that'll work. And so kind of by inspection, you could also solve this. And because -1 plus 1 is 0, and the absolute value of 0 is 0. I guarantee you won't be able to find a single other number that satisfies this absolute value. Okay, so everything makes sense so far? How about this? I'm going to apply the definition again. You're going to get very used to this definition. I mean, it's worth just being able to say and visualize in your head. So this is X. I assume people are now familiar with it, so I'll just write it. Right? And now each of these things is equal to 2, according to this equality. So I have these two statements. X plus 1 equals 2. Negative x minus 1, doing this distributive thing that someone wisely said, is equal to 2. Yeah.
Plus 1.
And so the solution to the first equation is that x is 1. And the solution to this equation is what?
This is -3.
Very good. Yeah. So okay, be careful here, right? We have some minus signs. So negative x is 3, and so x is -3. So look, you have two different solutions. Remember when we were talking about linear equations? And we said that the degree of a linear equation is 1, and that a line will cross the x-axis. Generally, it'll cross the x-axis once. Remember when we had this discussion? No, people don't remember. Okay, well, generally a line, this is a constant function. It's technically not linear, but any linear function that has this form will cross the x-axis at least once. No, not at least once, exactly once. And look, how many times does this cross the x-axis, so to speak?
Twice?
Yes. So when I say cross the x-axis, that's sort of making the analogy to 2D. There is no second dimension here. But in a sense, this equation has two solutions, and yet the degree of x is 1.
So would that be like 2 different lines?
It actually, yes, and we're gonna end up plotting sort of what this looks like. Okay, so absolute value can kind of do strange things, and we're going to get a much better visual sense in just a few minutes. Okay. Any questions about this question? Don't be shy. Who is very confused about absolute value? Don't be shy.
Not very confused, but a bit.
A bit confused. Okay, what is bothering you? Just this definition, or?
No, I just feel like I'm gonna have trouble because when I see someone do it, it makes sense, but I feel like I'm gonna have trouble figuring it out on my own.
On your own. Okay, so this lecture is being recorded, and I'll send it out, okay, to everyone. Yeah, the only way to, but you're very right. At least you're acknowledging sort of the way math is, and that is that you'll have to do it yourself. Trust me, I really struggled with this when I was in high school. And so I learned this in 10th grade, and this was like heavy stuff. So the ninth graders, I mean, just brace yourself.
Right, because I was in ninth grade and I did not learn this at all.
Okay, so yeah, and that makes sense because I think generally people learn this in 10th grade. It's sort of like Algebra 2, but it's definitely on the SAT. So if this is new to you, just brace yourself and go to the office. Please go to the office hours. Patricia is amazing. Her office hours today. Other people's are tomorrow. They love working with you, and they're very patient. I wish I could like really take time during the lecture, but we have just so much. Okay. So hopefully I'll just keep doing some examples and a little bit of it might rub off on you, okay? So this one, by the definition of absolute value, this is equal to, notice I'm using definition 3 in all of these problems. It's the most rigorous definition of absolute value. And so by that definition, we have this, and minus this if 2x plus 3 is less than 2.
So at this point, can we just start setting just the two equations by themselves?
Yeah, exactly. And so and that's the next step from, if I'm understanding what you're saying. You can
can we just start with this at this point?
You can start with this, but if you start with this, you might screw up at some point, on harder. Yeah, so many.
Yeah, harder problems, yeah.
Yeah. I even when I see this stuff, sometimes I go straight to this, but it's nice to think about the definition, right? Because if you start with the definition, you'll never go wrong. But here, when things become more sophisticated, it's a slippery slope. And sorry, this is positive 4. Look, I made a mistake. Okay, positive 4. This part comes just from the equality, from the statement of the problem. So the solution to this is what?
1/2.
Yeah, so 2x is 1, so x is 1/2, and the solution to the bottom one is
7/-2.
Good, so you already kind of did it. Yeah, so the way you do this is you add 3 on both sides, and from this you divide by -2, and you got -7/2. So again, look, seemingly linear equation, and yet 2 solutions. So something is going on. Something is going on, right? Okay, I think this is the last one of this. Let's see, I'll do this just for people's familiarity, okay? So people can kind of understand the process. So by the definition, right, that's all I'm doing here. In fact, okay, I'm gonna keep writing the definition so it becomes habitual for many of you, but Adi, if you want, you can go straight. For anyone else who feels comfortable or who has done this before, you can go straight to the statement of equalities, skipping the definition. Okay, so now I'm going to set these statements equal to 15. So I have 2 equations. 5x plus 10 is 15. And, what the heck? And that, right? So 5x is 5. Negative 5x is 25. So I'm doing the math fast because I assume we can all solve linear equations. Because that's all this is. This is just solving linear equations. And everyone should be comfortable with that. So I'll sort of blaze through. Again, 2 solutions. And if you want to check, we haven't really checked any. Let's check these solutions. Is 1 a solution? So this is saying 5 times 1 plus 10. Is that absolute value of that is indeed 15 because 15 is 15. Absolute value of 15 is 15. How about -5? So I'll put in -5 here. What is 5 times -5? That's -25.
-25.
Plus 10. That gives you -15.
And then absolute value.
From our middle school understanding of absolute value, absolute value of -15 is 15. So it works. Yay. Okay, let's throw in now. So now we've so far been talking about equalities with absolute value. Now let's mix inequalities with absolute value. And this is what the SAT people love, okay? So this isn't really a whole lot harder. You've gotten past the hard part, theoretically, with discussion of the definition of absolute value. But what does this mean? So from the definition, this means, I'll just write the definition. Absolute value of x is x if x is greater than 0, negative x if x is less than 0, right? And now x is great. So now I'm going to apply the equality. So x is greater than 1 if x is greater than 0. And negative x is greater than 1 if x is less than 0. Did someone? Okay. Okay. So these are actually, so how would you write this? You can multiply, this is sort of already solved for x, right? This one, you can multiply both sides by -1. And what happens to the sign when you multiply it?
It'll flip.
It flips. That's what we spent all day yesterday talking about, right? So this is the statement, right? Make sense? So you have two conditions, right? That x is, not two conditions, but two equations, and they both sort of limit x. If I were to draw this one-dimensional line, all lines are 1D. If I were to draw this one-dimensional plot, whatever you want to call it, look. From the first one, x is greater than 1. From the second one, x is less than -1. So all numbers greater than 1 and all numbers less than -1 satisfy this inequality. Make sense? This is something you should be able to do. Okay, using the definition, get this result. And if you want to check, look, pick 3 and -3. Both of these should supposedly be solutions. Well, absolute value of 3 is 3, which is greater than 1. And how about -3? Absolute value of -3 is 3, which is greater than 1. So we sort of have the right solution. Okay? Make sense, roughly?
Yes.
Okay. I know that this is sort of new to people, okay? So just hang tight, okay? If this will all make sense very soon, okay? Just a matter of practice, okay? Okay, let's do. Let's see. Okay, let's do this one, and then we'll move on to the last sort of few minutes. Okay, so by the definition of absolute value, 10x plus 5 is either 10x plus 5 if 10x plus 5 is greater than or equal to 0. Negative 10x plus 5, well, all negative, if 10x plus 5 is less than 0. Okay, now I'm going to apply the inequality. 10x, right? I'm now applying this. 10x plus 5 is greater than 20 if that condition is true. And now I'm going to distribute this. Actually, let's do it this way. For this condition. Okay, so again, two equations. We spent all day solving equations like each of these. So the first one is what? 10x is greater than 15, subtracting 5 on both sides. Okay, let's finish this top equation. So x is what? Greater than, dividing by 10 on both sides, 3/2. How about the bottom equation? No, sorry, the equality is not there. My bad. What about the bottom equation? Well, here we have to do sign flipping business, right?
Yeah, so it'll be -10x minus 5 is greater than 20.
Sure, but instead of distributing the negative sign and then dealing with it, why don't we just multiply it by -1 right now?
Okay.
To me, that would be easier, and I'll just do it, okay? So multiplying across by -1 gives that, notice that I flipped the sign because I've done this, right? Spent all day talking about y yesterday. Now, this is easy to solve. 10x is what? Less than negative.
Is that a J?
No, sorry, that's a 5. It's a 5.
Oh, okay. Sorry.
No, it's fine. Okay, and then x is less than what? 5/2. So I'm doing the math quickly because I assume, again, that you can all solve linear equations. So so how would I draw this?
Okay, so it would be 2 lines. One.
Well, it's one line.
Oh, on the number line. Oh, sorry. I thought you were talking about graphing it.
Right. So we have two statements. Here's the point. Okay. Here's the point -5/2. Here is 0, and here's 3/2, roughly. Okay. So the first one, open or closed circle?
It'll be open.
Right, because there's no equality here. And is it to the left or to the right?
To the right.
And what about this one?
Open left.
Yep. Okay, so we're kind of blazing through these examples. Okay. Oh, what the? I don't know what. My computer is not liking this. Okay, we're kind of blazing through the examples. If you're confused, please go to the office hours. I'll stick around for a few more minutes at the end here to clarify some things. Now let's venture into 2D. Okay, so remember we had our parent function y equals x, and what did this look like? Just a line, right? Y equals x, and it had all these points like 1, 1, 2, 2, right? Now what happens if you take the absolute value of x?
It'll go in two separate directions.
It'll go in two separate directions. So why? So what do we know about the absolute value of x? Can it be negative?
No.
No. So can any of this exist? This is the negative y, right? This is
unless it's like flipped vertically, it can't.
Right. So what the absolute value is going to force us to do is this entire part is going to get reflected up here. And if you want to sort of test this out, you can put in some numbers. Remember I said plotting is like kind of frowned upon because it's very elementary. Well, let's just do it for a few numbers and see. So what is absolute value of -5?
5.
Yes. What is absolute value of -3?
3.
0, 0.
0.
So indeed, if I were to plot these points, look, -5, 5, -3, 3, 0, 0. Then it's reflected, right? 3, 3. Okay, so I drew this badly, but 3, 3, 5, 5. You can see that putting the absolute value is like putting a mirror up to the y-axis in this case, right? And it just gets flipped. So let's sort of apply that. Now we don't have to like draw a table. We can just apply, right? So what does this graph look like?
It's a V, but it's up one.
What does this look like?
That'll just be a linear line. Yeah.
Okay, so a linear line. It's okay.
Oh, sorry.
Okay, and now we know what can this part exist?
No, it can only hit once y hits 0. It goes the opposite direction.
Yeah, exactly. So you're sort of catching on, and so you can see that when you put an absolute value across the entire like right-hand side, right? If all the x stuff, if all the stuff is written on one side, then this is just like putting a mirror up to wherever the x-intercept is, right? This is the x-intercept. What is this point? What is this point of reflection, so to speak? Well, what is the x-intercept?
The origin.
No, it's not the origin. This is the origin. It's not the.
Oh, okay.
What is this point? You could. This is
-1.
It is -1. Yeah, kind of by inspection again. But if you wanted, you could put in, x-intercept is -b/m and go from there, and you would get -1. Okay, so the line of reflection, they might ask this on the SAT, the line of reflection is x is -1. It's a vertical line. Okay? Okay, so I'm going to stop and we'll continue with a few of these tomorrow and then sort of rehash, okay? So we sort of talked about a lot today. It's okay if not all of it made sense, or honestly, if none of it made sense. That's why I didn't want to do a quiz, because I know this is something that comes with practice, and it's not really fair, right? If I make the 9th and 10th graders like take a quiz on something they just are seeing for the first time. Okay, so you can leave if you want. You can stay if you have questions. And there are office hours at 1 today.
Thank you so much.
Yeah, you're welcome.
Could you do another example with the greater than or less than sign? I said please.
For question number 3 in our homework,
Uh-huh.
it says to graph in a 2D, right? So we just graph the line. I mean the
Sorry,
equation.
I'm a bit split focused here with the chat. On question number which?
3.
3. Okay, I'm looking for it. Question number. Yeah. So okay. So let me copy and paste. So it says graph in 2D. So that's sort of what we were doing at the end of the lecture. And so I'm going to talk more about this tomorrow.
Okay.
But
So
here I'll kind of guide you through it. Okay, you can see this. Okay, so this is the question, right? And
yes.
I said to graph into. So what would the equation version look like? So what would that look like? So we sort of made, when we talked about this is slow, this computer. When we started talking about inequalities, we started making this comparison between inequalities and equalities, right?
Yeah.
And I said that there's some value in comparing inequalities to equalities. And so I'm going to ask you to make that comparison. So this is a linear equation, right?
Mm-hmm.
And what, do you recognize the form of it? Kind of maybe reminiscent.
Oh, okay, yes.
Yeah, and so what's the slope?
The 10.
Yeah, well, your slope is m. And what's the y-intercept?
The B.
And what is that here?
5. Negative 5.
Negative 5. So what does this line look like? So what is the y-intercept? That's the point where the line meets this axis, the y-axis.
The y-axis.
So where is negative 5 on this axis?
Below the x-axis.
Right, and it's at the point 0, comma, negative 5. And what is the meaning of the slope? That means that it's pretty steep, right? For 10.
Yes.
And how would we find, so the line is going to look something like that. And how would we find that point? We talked about this earlier. This is the X-intercept. How would we
Yes.
find it?
X-intercept.
Do you remember this? We talked about this earlier.
Yes.
And you know where this comes from, right? This comes from
like
setting.
0.5 or something.
Is it 0? That's actually right. Yeah. And so minus b, it should be 1/2, right? Which is 0.
Yes.
So minus b is, minus 5. M is 10. Minus 5 is just 5. So that's 5/10, which is 1/2. So yeah, so this is the point 1/2, comma 0. So we have the line. Now how do we apply the inequality? It's less than or equal to, right?
Yes.
So first of all, is the line going to be dashed or solid?
Solid.
Right, because of the equal to, right?
The equal to.
And is the shading going to be above or below?
Below.
Right, because its y is
less than.
So you're going to just shade. So this is the solution to the problem.
Oh, okay. So we just put the graph as the answer, or do we have to do all of this that you just showed me?
Let me look back. I think that's all you need. Yeah, I just said graph the following inequalities.
Okay, so it's just the graph, not
Just the
really the y, x,
Yeah, I mean, it would be nice to have some points on your line so you can show that you need at least 2 points to define a line. So try to put at least 2 points on there.
Oh, okay. So it's just the graph. Okay.
It's just the graph. Yeah,
I was planning to do like the whole entire work, this, but I think it's just the graph.
Yeah, I don't know what else you could do here. So note that this example does not involve absolute value.
Oh, okay.
Right? What we talked about today has nothing to do really with this. So this is what we talked about yesterday. So you can watch the lecture again. It's on YouTube.
It's on YouTube. Okay.
If you want me to send it to you, I can. I don't want people to start really depending on the YouTube recorded lectures, but it's there if you need it. Thanks everyone for coming. Does anyone else have any questions?
Thank you.
Sure, you're welcome.
Thank you.
Sure, you're welcome. Great. Okay, I'm gonna assume no one has questions.